This lesson is on solution stoichiometry. So we're going to be using the mole ratio that we learned back in the last unit, but we're going to apply that knowledge to solutions and see what happens. First thing we got to look at is the difference between solution and gravimetric stoichiometry, or stoic. And really the only difference is, gravimetric stoichiometry, that's what we did in Unit 3, okay? That's using masses. Okay, so grams and converting that to moles, okay? Now we're looking at solution stoichiometry, and really the only difference is how we find our moles. So if you look, we have to use that moles is C times V, so concentration times volume, instead of using our moles of mass divided by the molar mass. So as long as we know how to calculate moles, given a concentration and a volume, everything else is actually the same, and it should be pretty straightforward. So if you are the type that likes steps, these are already in your notes. So this is what I'm going to go through with you guys. So step 1, you need to have a balanced chemical reaction, and it needs to be balanced so that we can use the coefficients in our mole ratio. Step 2, convert from the concentration or volume that you're given into moles. Step 3, you're going to use the mole ratio to calculate the amount that's required in moles. And then step 4, you're going to convert that to whatever unit I ask you to find. It's usually volume, but it can also be concentration. But let's go through a couple of examples together and see if we can get this figured out. So what volume of 15 molar ammonia would be required to react completely with 1.5 liters of 12.9 molar phosphoric acid according to the following reaction? So the actual answer to this question is 3.9 liters. So let's see if we can actually get to that. So we're first going to start off by balancing our equation. So if you have a look here, in order to balance the equation, I need 3 nitrogens here, and 1 and 1. And I also like to write what's given to me in the question underneath the different parts of the reaction. Okay, so what I'm given is I'm given 15 molar NH3. That's a concentration. So that's my concentration of NH3, 15.0 molar. I'm also given 1.5 liters of 12.9 molar H3PO4. So that's my concentration is 12.9 molar, and my volume here is 1.5 liters. So the question is, what volume of ammonia, so I need to find my volume of ammonia here, is required to react completely with this phosphoric acid? Now if you look here, this starts to look a lot like the dilution equation, C1V1 equals C2V2. But you cannot use, don't use C1V1 equals C2V2. Okay, that is the dilution formula. This is not a dilution, this is a chemical reaction. So I'm allowed to use the dilution formula if I'm only adding water or if I'm doing a dilution, but that's not the case here, so I cannot use C1V1 equals C2V2. That's a common mistake that people make, so don't be that person that I make fun of in class. All right, so step 1, I have to convert whatever I'm given into moles. So here, I basically need to find the moles of both of these things in order to be able to answer my questions. So if I look here just for a second, and you don't have to write this down, if I want to find the volume here, the volume is actually going to be moles over concentration. Well, I gave you concentration in the question, but I didn't give you moles. So we're going to have to find moles using our information over here, and then once we find it, we can plug it into that formula and solve for volume. So that's our sort of problem-solving strategy. So we're going to start by finding the moles of my phosphoric acid. So I'm going to do this in red because it has to deal with the red. So moles of H3PO4, okay, is going to be C times V. So it's 12.9 molar times 1.5 liters. And I only have my final answer here, so I'm punching this into my calculator as we go. So I get 19.35 moles of H3PO4. Now what I'm going to do is change that into moles of ammonia. So I'm going to use my stoichiometric ratio to do that. I'm just going to scroll down a little bit here. So if I'm going to do this in blue, so to find the moles of NH3, I have 19.35 moles of H3PO4. And I'm going to times that by my conversion factor. Moles of H3PO4 goes on the bottom to cancel. And moles of NH3 goes on the top. So that's the unit that I keep. And the numbers that go in there are my numbers from my balanced chemical equation. So 3 and 1. So the 1 goes with the H3PO4, the 3 goes with the NH3. So I take my answer and I times it by 3, and I get 58.05 moles of NH3. Now the final step is going to be to calculate the volume. So volume is moles over concentration. So now I take my 58.05 moles and I divide it by the concentration that was given to me in the problem, which was 15 molar. So if I do that, I get 3.87 liters. And what I have to do at the end is remember to round to my right number of significant digits. The smallest number of significant digits in the question was my 1.5 liter, so I have to round this to 3.9 liters. So there is my final answer, and that's what I actually had at the start of my problem. Okay. So next question. I'm going to do this one all in one step. So in an experiment, I've got a 5 milliliter sample of sulfuric acid reacting completely with 15.9 milliliters of 0.150 molar potassium hydroxide. Calculate the molar concentration of the sulfuric acid. So I have the answer there, again 0.238. If you want to try this on your own and see if you get there, you can pause the video now and do that. So the first thing I need is a balanced chemical equation. Sulfuric acid is H2SO4. Potassium hydroxide is KOH. So I end up with K2SO4 and water. I need to go back and balance it out. So I put a 2 here, and I'm balanced. And these are all aqueous. This is aqueous. This is aqueous. And H2O is a liquid. All right, so there's my balanced chemical equation. So it's asking me to find the molar concentration of your H2SO4. So I don't know what that is. So let's write down what I do know. I know I have, so my concentration I don't know, but I know I had a 5.00 milliliter volume. Remember to convert all your volumes to liters, so 0.00500 liters. And then for my potassium hydroxide, I had a concentration of 0.150 molar, and I have a volume of 15.9 milliliters. And again, convert that to liters. So it's 0.0159 liters. I divide by 1,000. Again, it's set up to look like C1V1 equals C2V2, but that doesn't work because my ratio is a 1:2 ratio. So have a look at that and make sure that you understand that you cannot use your dilution equation when there's an actual chemical reaction happening. So if I'm going to do this all in one step, this is what it would look like. So I start off with my volume and concentration of my potassium hydroxide. So I have I'm going to color code this for you, so I'll start that in green. So I'll do 0.0159 liters of KOH, and I'm going to times that by 0.150 moles per liter. So that's my C times V. Then I'm going to times it by my mole ratio. Again, I want to cancel out KOH. So moles of KOH goes on the bottom, and moles of my sulfuric acid, H2SO4, goes on the top. And the numbers that I get are from my balanced chemical equation. So I have a 1:2 ratio. Now I'm going to multiply that again by what's given to me in the question about H2SO4. So in this case, I have to divide it in this case. I have 1 over 0.00500 liters. So that's how you would do it all in one step. If that doesn't make any sense to you, then use the 3 steps that I showed you on the last example. And basically, if you punch all these numbers into your calculator, you end up with a concentration of 0.238 molar. Go back to your question, check your significant digits. They're good. I've got my units. That's good. And I'm done with my question. So that's how you would sort of do it all in one line or all in one step. What I'm going to do right now is I am going to leave the last 2 questions for you to try on your own. I'm going to put them up really quick so you can see the final answer and try them. And those are going to become the check your understanding for this video. So for the next example, your answer that you should get should be 8.6 grams. So you can try that one on your own. And then the last example, your yield, the percent yield of the reaction, is going to be 87%. So try these ones out on your own, see if you get them. And if you don't, I promise I will take them up in class. That will be the first thing we do when you come to class this time.